All right, so let's get started. This is a problem. We have a frame, and we're going to want to find the displacement at joint C, which is out here on the end. And we'll start with just doing the energy from bending. So I'm going to need to first find equations for the moment in each of these sections for this real force system, and then redo it for the virtual system. Now my question to you is, do I necessarily need the reactions to do this problem?
No.
I say no. There's other ways to do it. I'm going to think about the moment in AB. When I make my cut here, I'm not going to look at the bottom section. I'm going to look at this top section. And then when I make my cut here in BC, let me go ahead and draw those so that you can see them. If I make a cut here to find this moment, if I did do the bottom section, I would need the reactions. That's not hard to do, but let's not do it this time. Let's try just using the upper part of the structure for our free body. And then when I make a cut here in BC, I think you'll agree with me that looking at this segment over here to the right will be easier. So let's start with that. So I'll come over here and I'll begin by looking at the section AB. So when I make this cut, right? I've got my applied force here of 10 kips. And then what else do I have? I've got this part of the distributed load. Oops, sorry.
That'd be half.
That has an intensity of half a kip per foot. Now, I'm going to arbitrarily call this distance that I'm going to integrate here, I'll just call it y. So now I'm going to come up with the concentrated equivalent force for that section. And what would it be?
49 times height.
Right, it's going to be the height, which is a half kip per foot, times the distance y. So really it's going to be y over 2. And the distance to the centroid is also y over 2. Everybody see that? So now if I come and I'm interested in the moment, the real moment in this section from A to B, you know what, I think I'll go ahead and while I'm here get the force in AB. That will be my axial force, and we'll use that later. So now I'll come and some moments about the cut. Make sure it's in equilibrium. And what do I have? Well, I have my internal moment, which is negative. I have the moment due to the applied load, which is also negative. And it has a force of y over 2 with a moment arm of y over 2. Then I have my 10 kip force out here on the free end. It's also negative, and it has a moment arm of 10. So when I solve for my moment in AB, it looks like I get, everything's negative, so it looks like I get negative y squared over 4 minus 100. Right? And the units of that whole thing should be kip feet. Everybody see that? And then I can sum my forces. In this case, I'm looking for this force, which is in the y direction. I assumed it act down, so that would be minus FAB. This is a horizontal force, don't have to consider it now. And then there's my other force, so it's also down. So it looks like my force is minus 10, which means it's in compression. I think that makes sense. Oops, sorry. I need to get some tape this sheet down, keep it from running away. So far, so good? All right, let's do the next section. From B to C. Now, you may have noticed that the skills that we're using are just finding moment and forces at internal sections. We've been doing this since about the second or third week. So these basic skills just keep coming back. So don't forget, when we go back on the final, for the first part of the final, there's going to be problems that are just going to be that. So I'm expecting you all to do much, much better on part 1 of the final because they become very fundamental to us. Hopefully you've found a way to make it work for you. So here's my section here with my 10 kip load out here on the end. And I'm going to decide to measure this one in this direction. And I'll call that distance x1. And I'm going to be looking for the moment there, and that will be the moment in BC. And I'm going to be looking for the axial force. I'll assume it's tension, and I'll say that's the tension in BC. So if I sum moments of this free body diagram and sum them about the cut surface, make sure they're in equilibrium, what do I get? Well, using right-hand rule, this is a negative moment, BC. And this 10 kip force also creates negative moment and has a moment arm of x1. So it looks like the moment in BC is equal to negative 10 x1. And again, it has units of kip feet. Okay? Questions about that? Okay, then we'll sum forces. This case in the x direction, because I'm looking for the axial force, so that's negative. And I drew that wrong. Sorry. X direction positive. We're not doing y. So I get BC, and that's it. So there is no axial force in section BC. Now I know I'm running out of time, but I think I can write the virtual work equation. I can't. I might be able to. No, I won't be able to. I'll have to stop here. So what I'll do is, I think what I'll do is I'll finish this problem for you on Tuesday. So what I'll do is I'll end up posting the solution in 2 parts. There'll be a part 1 which is up to this point, and then you'll click it off if you choose to watch it. And when you start up the companion one, I'll just pick up here. I'll try to give you 3 of these to work over the weekend that are as simple as I can come up with. And I'll focus just on the bending and the axial.
Bring our computers on Tuesday.